This is chapter 5, test question help, problem number 21. The question states, use the rational zeros theorem to find all the real zeros as a polynomial function. Use the zeros to factor f over the real numbers. Okay? Our function that is given is 5x cubed minus x squared plus 5x minus 1. Okay? Step 1. We are going to use our degree to determine the maximum number of zeros. So, in this case, our degree is 3. So we are going to have at most 3 real zeros. Step 2. Use Descartes' rule of signs to solve for the positive and negative possible real zeros. Okay? So this is the function, the original function. I rewrote it. We are going to use Descartes' rule of signs to find how many possible positive real zeros are. When you're doing the positive ones, you use the original function. So we're going to look for the number of times that the sign changes. So the sign changes here, that's 1. Sign changes here twice. Sign changes here 3 times. So the sign changes 3 times. So we will either have 3 or 1 positive real zero. Descartes' rule of signs states that once you have determined the sign change, you can go down 2 from that. Okay, so if it was at 5, it could be 3, 1. You go down by 2s. Okay. Now let's determine the number of negative real zeros. So in order to determine the negative real zeros, okay, you are going to plug in a negative x for each of your x's. So when we plug in a negative x cubed, we are going to end up with a negative x. Negative x times 5 is going to be a negative x cubed. We are going to plug in a negative x and have negative x squared. Negative x squared would be a positive x squared, and then this positive x squared that by the times the negative x squared would be negative x squared. Next, we're going to put in negative x for just x. When we multiply negative x times 5, we're going to end up with negative 5x. And lastly, our constant is just going to stay the same. Okay? So now let's look how many sign changes do we have here. We went from negative to negative to negative. We had 0 sign changes. Because we had 0 sign changes, we are going to have 0 negative zeros. The next step is to determine our potential real zeros. Okay? In order to determine our potential real zeros, we look for the factors of our constant and the factors of our leading coefficient. So, factors of our constant, and you find the integer factor, so it can be a positive or a negative. So we're going to have plus or minus 1 over plus or minus 5 plus or minus 1. Okay, these would be separate. So you could list them all out. You would have 1 over 5, negative 1 over positive 5, right? You can list them all out. In the end, the only possible potential positives are going to be 1 and negative 5. Now, a unique thing about this is we can use this. If we look here, we have 2. If we look here, it says we're going to have 3 or 1. So therefore, both of these are not going to be our positive real zeros. They're not both going to work. We cannot have 2 positive real zeros. However, we're going to have 1. We can't have 3. And at most, we were going to have 3 real zeros. We had 0 negative zeros. So one of these is going to need to work. One of these will satisfy our function. Okay? Step 4, we need to test our potential rational zeros by using synthetic division. You also could test the potential positive real zeros by substituting in that number for x. If you substitute in that number for x, your function should equal 0. If your function equals 0, then that number is a real 0 of your function. Okay, so step 4 is to check with synthetic division. I just rewrote our function right here for us, and we know that we have either a possible real 0 at 1 or at negative, or 1 or 1/5. We're not going to have both of them. Both of them are not going to satisfy our function. All right, so I am going to start by checking 1. I always start with 1. Okay, I'm going to cover this up really quick, and I'm going to explain where these numbers come from. These numbers in here come from our original function, 5, 5. The coefficient for this one is -1, -1. Coefficient here is 5, 5. Constant, -1, -1. Okay, and then we're going to put the 1 on the outside. That's what we are going to be dividing by. Okay, all right. So when we do synthetic division, okay, the 5 comes down. Now we are going to take 1 times 5. This is a times, okay, times going down. So 1 times 5 is 5. That number comes here. Okay. Now we are going to add these two numbers together. So -1 plus 5 is 4. Again, we're going to multiply this way. So 1 times 4 is 4. Add these. That's going to be 9. 1 times 9 is 9. Add. We're going to end up with 8. No, 1 is not a potential real 0. No, because this number right here, should be 0. That's what we should have been. That's what we should have gotten if it was a real 0. It is not. Okay, we're going to check negative. I keep saying negative. It's not negative. It's just a fraction. Sorry. We're going to check 1/5 next, using those same coefficient numbers, so we can check them. I'm going to bring my 5 down. 1/5 times 5 is 1. Add these together, 0. 1/5 times 0 is 0. 5 plus 0 is 5. 1/5 times 5 is 1. -1 plus 1 is 0. Yes, it does work. So 1/5 is a real 0 of our function. Okay? Since 1/5 is a real 0 of our function, x minus 1/5 is a factor of our function. Okay? We also need to find the other factor of our function, and in order to find the other factor, we are going to use the remainder from our synthetic division. So, our remainder from our synthetic division, I just rewrote this here, and then I rewrote that, and then also here is the original function. This is our original function, and I'm going to explain how we can rewrite this based on that. So you're going to use your remainder, and you use your original function. So your original function is 5x to the third. You go down 1 degree from here. So you're going to go down 1 degree, okay, which would be 2, and you're going to put that here. So it's 5x squared, okay, 5x squared. This would be our x. This would be our constant. And the nice thing about this division is that because of it, this should be nothing, right? This should be our constant. It should end there. So when we rewrite this, we're going to have 5x squared plus 5. Now, we would not want to leave it like this. We want a leading coefficient of 1 here. So factor out 5x squared plus 1. So our real factors of this, or factors of this problem, are going to be at 5x squared plus 1, x minus 1/5.